Top 25 Mechanical Engineer Interview Questions and Answers. In the competitive field of mechanical engineering, preparation for interviews is crucial. This video will outline the top 25 interview questions commonly posed to candidates, along with well-crafted answers to help you stand out. Whether you're a recent graduate or an experienced professional, understanding these questions will boost your confidence. Join us as we explore essential topics that demonstrate your skills and knowledge in mechanical engineering. 1. What are the laws of thermodynamics? Explain each briefly. The laws of thermodynamics are fundamental principles that describe energy interactions. 1. Zeroth law. If two systems are in thermal equilibrium with a third system, they are in thermal equilibrium with each other. This establishes the concept of temperature. 2. First law. Energy cannot be created or destroyed, only transformed. This law introduces the principle of conservation of energy in thermodynamic processes. 3. Second law. In any energy conversion, entropy of a closed system tends to increase. This law explains why processes are irreversible and energy transitions are not 100% efficient. 4. Third law. As temperature approaches absolute zero, the entropy of a perfect crystal approaches zero. This law implies that absolute zero is unattainable in physical processes. 2. How does a four-stroke engine work? A four-stroke engine operates through four distinct strokes: intake, compression, power, and exhaust. During the intake stroke, the piston moves downward, creating a vacuum that draws in an air-fuel mixture through the open intake valve. Next, the compression stroke seals the mixture in the cylinder as the piston moves upward, raising the pressure and temperature. The spark plug ignites the mixture during the power stroke, forcing the piston down and generating power. Finally, the exhaust stroke expels combustion gases as the piston moves back up, closing the exhaust valve. This cycle repeats continuously, enabling engine operation. 3. What is the difference between HVAC and refrigeration systems? HVAC stands for heating, ventilation, and air conditioning, while refrigeration systems are primarily focused on cooling. HVAC systems regulate indoor climate by heating, cooling, and circulating air, ensuring comfort in residential and commercial buildings. They incorporate components such as furnaces, air conditioners, and ductwork. In contrast, refrigeration systems are designed specifically for removing heat from a space or substance, often using refrigerants to achieve low temperatures. These systems are commonly found in refrigerators, freezers, and industrial processes. While both systems involve temperature control, their applications and components differ significantly. 4. What is the significance of entropy in thermodynamics? Entropy is a measure of disorder or randomness in a system. It plays a crucial role in thermodynamics by indicating the direction of spontaneous processes. In a closed system, entropy tends to increase, signifying that energy disperses and becomes less available for doing work. This concept reinforces the second law of thermodynamics, which states that energy transfers are not 100% efficient, leading to heat loss. In practical applications, understanding entropy helps engineers design more efficient systems, analyze energy flow, and improve sustainability in processes. 5. Explain the concept of stress and strain. Stress and strain are fundamental concepts in mechanics of materials. Stress refers to the internal resistance of a material to external forces, measured as force per unit area, N per square meter. It is typically classified into types such as tensile stress, compressive stress, and shear stress. Strain, on the other hand, represents the deformation or change in shape of a material due to applied stress, expressed as a ratio of change in length to original length. These two concepts are interrelated. Stress causes strain, and the relationship is often described by Hooke's law, which states that stress is proportional to strain within the elastic limit of the material. 6. What is the difference between laminar and turbulent flow? Laminar flow occurs when fluid moves in parallel layers with minimal disruption between them. This type of flow is characterized by smooth, orderly motion, usually at low velocities and with low Reynolds numbers. In contrast, turbulent flow is characterized by chaotic and irregular fluid motion, where eddies and vortices form, typically occurring at high velocities and high Reynolds numbers. The transition between these flow types can significantly impact heat transfer, pressure drop, and overall system efficiency in various engineering applications. Understanding these differences is crucial for design considerations in fluid systems. 7. Define the term factor of safety in design. The factor of safety, FOS, is a design principle used to ensure that structures or components can withstand unexpected loads or conditions. It is defined as the ratio of the maximum load a material can endure without failure to the actual load applied. A higher FOS indicates greater reliability and safety, accounting for uncertainties in material properties, loading conditions, and potential flaws. Commonly, FOS values range from 1.5 to 3, depending on the application and consequences of failure. This principle helps engineers create safer and more robust designs in various fields, including mechanical, civil, and aerospace engineering. 8. What are the common materials used in mechanical design and why? In mechanical design, common materials include steel, aluminum, plastic, and composites. Steel is favored for its strength and durability, making it ideal for structural components. Aluminum is lightweight and has excellent corrosion resistance, suitable for applications where weight is a concern. Plastics are versatile, cost-effective, and used in various products due to their ease of fabrication. Composites combine materials to achieve superior strength-to-weight ratios, making them ideal for aerospace and automotive applications. Each material is selected based on specific mechanical properties, cost, and application requirements. 9. Describe the working principle of a centrifugal pump. A centrifugal pump operates based on the principles of fluid dynamics and centripetal force. It consists of an impeller, which is a rotating component that imparts kinetic energy to the fluid. As the impeller spins, it creates a low pressure area at the inlet, drawing fluid into the pump casing. The fluid is then accelerated outward by the impeller's blades, converting kinetic energy into pressure energy. This pressurized fluid is discharged through the pump outlet. The design allows for efficient fluid movement, making centrifugal pumps ideal for various applications, including water supply and chemical processing. 10. What is the role of a flywheel in an engine? A flywheel serves as a mechanical energy storage device that helps maintain a consistent rotational speed in an engine. It absorbs energy during the power strokes and releases it during periods of low power output, smoothing out the engine's operation. This helps reduce fluctuations in torque and enhances engine efficiency. Flywheels also aid in starting the engine by providing the necessary momentum. Their mass and design can significantly influence the engine's performance characteristics, including acceleration and responsiveness. 11. How do you calculate the efficiency of a heat exchanger? The efficiency of a heat exchanger can be calculated using the formula. Opening square bracket, text, efficiency, equals, frac, Q underscore, text, actual, Q underscore, text, max. Closing square bracket, where, Q underscore, text, actual, is the actual heat transfer rate, and Q underscore, text, max, is the maximum possible heat transfer rate. To determine these values, measure the inlet and outlet temperatures of both the hot and cold fluids. The heat transfer rate can be estimated using the following equation. Opening square bracket, Q equals M, C dot C underscore P, C dot T underscore, text, in, T underscore, text, out. Closing square bracket. This method accounts for mass flow rates and specific heat capacities, providing a clear understanding of the heat exchanger's performance. Proper maintenance and design adjustments can enhance efficiency. 12. What are the advantages of using CAD software in design? CAD software offers numerous benefits that enhance the design process. It allows for precision and accuracy, enabling engineers to create complex models that can be easily modified. This software improves collaboration among teams, as designs can be shared and reviewed in real time. Additionally, CAD facilitates simulations and analyses, helping identify potential issues before physical prototypes are made. The integration of automation tools within CAD can significantly reduce design time, leading to increased productivity. Cost savings can also be realized by minimizing material waste through optimized designs. 13. What is the difference between welding, brazing, and soldering? Welding, brazing, and soldering are all processes used to join materials, primarily metals, but they differ in techniques and applications. Welding involves melting the base materials and adding a filler material, creating a strong bond upon cooling. It requires high temperatures and is used for structural applications. Brazing joins materials by melting a filler metal that has a lower melting point than the base metals, typically above 450 degrees Celsius. This method is useful for joining dissimilar metals and provides a strong joint. Soldering uses a filler metal with a melting point below 450 degrees Celsius, commonly employed in electronics and plumbing, where precise control of heat is essential to avoid damaging components. Each method serves specific needs based on material properties and application requirements. 14. Explain how a hydraulic system works. A hydraulic system operates based on Pascal's principle, which states that when pressure is applied to a confined fluid, it transmits that pressure equally in all directions. The system typically consists of a pump, hydraulic fluid, cylinders, and actuators. The pump generates pressure by drawing hydraulic fluid from a reservoir and pushing it through hoses or pipes into cylinders. As the pressure builds, it moves pistons within these cylinders, converting hydraulic energy into mechanical energy. This process allows for controlled movement and force generation, making hydraulic systems ideal for lifting heavy loads or powering machinery in various applications. 15. What is fatigue failure and how can it be prevented? Fatigue failure refers to the progressive structural damage that occurs when a material is subjected to cyclic loading. This type of failure often results from repeated stress, which leads to the formation of micro cracks that eventually grow and lead to catastrophic failure. To prevent fatigue failure, engineers can employ several strategies: selecting materials with high fatigue strength, designing components to minimize stress concentrations, performing surface treatments to enhance resistance, and conducting regular inspections to detect early signs of fatigue. Proper maintenance and adherence to safe loading conditions are also crucial for prolonging component life. 16. How would you optimize a mechanical component to reduce weight without compromising strength? To optimize a mechanical component for weight reduction while maintaining strength, I would start by analyzing the material properties and structural requirements. Selecting advanced materials like composites or high-strength alloys can significantly reduce weight. Utilizing finite element analysis, FEA, helps identify stress concentrations, allowing for design adjustments such as incorporating hollow sections or varying wall thicknesses. Implementing topology optimization can also lead to innovative geometries that minimize material use without sacrificing performance. Lastly, considering manufacturing techniques like additive manufacturing can enable complex designs that further reduce weight. 17. If a machine is overheating, what steps would you take to diagnose the issue? To diagnose an overheating machine, first, check the cooling system for proper function, ensuring coolant levels are adequate and there are no leaks. Next, inspect for blockages in the airflow or cooling fins. Evaluate the operating environment. High ambient temperatures can exacerbate overheating. Examine the machine's load conditions, as excessive loads can cause overheating. Monitor the temperature readings of critical components using thermal imaging or infrared thermometers. Finally, review maintenance records for any missed servicing or component wear that could affect performance. 18. Describe how you would handle a sudden failure in a production line. When faced with a sudden failure in a production line, immediate assessment is crucial. First, I would halt operations to prevent further damage or safety hazards. Next, I would gather a cross-functional team to diagnose the issue quickly. Each team member's expertise can provide insights into potential causes. Using root cause analysis, we would identify whether it's a mechanical failure, software glitch, or operational error. Communication with affected staff is essential to keep everyone informed. Once the issue is resolved, I would implement preventive measures and conduct training sessions to minimize future occurrences. 19. How do you select the right bearing for a particular application? Selecting the right bearing involves several key considerations. First, assess the load type, radial or axial, and magnitude. Next, consider the operating speed and temperature range, as these factors influence bearing type and material. Environmental conditions, such as exposure to moisture, dirt, or chemicals, also play a crucial role in selection. Additionally, consider the required lifespan and maintenance needs. Finally, consult manufacturer specifications and standards to ensure compatibility with the specific application requirements. Proper selection enhances performance and reliability, ultimately leading to efficient operation. 20. What is your approach to solving a fluid flow problem in piping systems? To solve a fluid flow problem in piping systems, I first gather all relevant data, including fluid properties, flow rates, and system geometry. I then conduct a thorough analysis using the principles of fluid dynamics, applying Bernoulli's equation and continuity equations. Computational fluid dynamics, CFD, software can be utilized for complex systems to visualize flow patterns and identify potential issues such as turbulence or blockages. Testing and validating the model with empirical data ensures accuracy. Lastly, I may recommend modifications or improvements based on findings, ensuring efficient and safe operation. 21. Describe a challenging engineering problem you solved. One challenging engineering problem I faced involved a malfunctioning production line that was causing significant delays. The issue stemmed from a conveyor system that frequently jammed. I initiated a root cause analysis, identifying misalignment in the conveyor belts. I collaborated with the maintenance team to redesign the alignment mechanism, incorporating adjustable mounts for better precision. After implementing the changes, we conducted rigorous testing to ensure optimal performance. The solution not only reduced downtime by 40% but also enhanced the overall efficiency of the production line, saving time and resources. 22. How do you ensure your designs are safe and cost-effective? Ensuring safety and cost-effectiveness in designs involves a systematic approach. First, I conduct a thorough risk assessment to identify potential hazards associated with the design. Utilizing simulations and analysis tools helps predict performance under various scenarios. Selecting appropriate materials that meet safety standards while staying within budget is crucial. Regular consultation with cross-functional teams ensures that all aspects, including manufacturing processes and maintenance, are considered. Additionally, I prioritize adhering to industry standards and regulations, which guide safety measures while keeping costs manageable. 23. Have you ever worked with cross-functional teams? What was your role? Yes, I have worked with cross-functional teams on several projects. My role typically involved collaborating with members from different departments such as design, production, and quality assurance. I acted as a liaison, ensuring that all technical requirements were clearly communicated and understood. This required facilitating discussions, organizing meetings, and synthesizing input from diverse perspectives. By fostering a collaborative environment, we were able to develop innovative solutions that met project goals while addressing various constraints. Building rapport and understanding each team member's expertise were key aspects of my role in these projects. 24. How do you stay updated with the latest developments in mechanical engineering? Staying updated with the latest developments in mechanical engineering involves several strategies. I regularly read industry journals and publications such as ASME and IEEE. Attending conferences and workshops allows me to network with professionals and learn about emerging technologies. Online platforms like Coursera and edX offer courses on new tools and methodologies, which I find beneficial. I also participate in professional organizations that provide resources and webinars. Engaging in forums and discussion groups helps exchange ideas and insights with peers, keeping me informed on current trends and advancements. 25. Describe a time when a project didn't go as planned. How did you handle it? In one instance, I was leading a project that involved the design and implementation of a new mechanical system. Midway through development, we discovered that a key component was not meeting our performance specifications. This setback threatened our timeline and budget. I organized an emergency meeting with my team to review our options. We brainstormed alternative designs and sourced new suppliers for the component. By reallocating resources and maintaining clear communication, we adjusted our schedule and successfully delivered the project, albeit with a slight delay. This experience taught me the importance of adaptability and teamwork in problem solving. In this video, we've explored the top 25 mechanical engineer interview questions and their answers, equipping you with the knowledge needed to excel in your next interview. Understanding these questions will help you demonstrate your technical skills and problem-solving abilities effectively. Remember, preparation is key to success in any interview. If you found this content helpful, please give it a thumbs up and subscribe to our channel for more informative videos. Your support motivates us to create even more valuable resources for aspiring engineers like you. Thank you for watching.